So it is November 8th, and I wanted to upload a little bit of a climate update because a couple of important things were put out on 2 days ago on November 6th. One is an updated ENSO forecast, basically. ENSO being El Nino, right? El Nino Southern Oscillation. Another thing that was posted a couple of days ago was this kind of big deal, 6 sigma global sea surface temperature event. I'm going to be putting that in context a little bit later. I'm also going to do a little bit of update on sea ice regrowth for this fall so far, being kind of rapid. But first of all, let's take a look at the most recent El Nino update as posted 2 days ago. Really, a couple of things worth noting in this report. It kind of tracks sea surface temperature developments across the central, I should say, equatorial Pacific. Where it shows, okay, so this is our El Nino for this year so far. It's kind of been wavering a bit. It's been, it's been a considerable El Nino, clearly El Nino, moderate to strong, but not the strongest we've seen. So, a little bit further down here in the report, which you can go and look up for yourself if you'd like. Of course, it has some definitions which are helpful, and we've got some things to compare it to. Something that was helpful to me, just because I like to see these things in context, would be we could compare current El Nino deviations from what we saw during the 2015, which comparable to the 1997 was about the biggest departures we've seen. And we can compare to the 2015 El Nino and see that we're not as strong as that El Nino. We would have had a 2.2 degrees Celsius deviation during this comparable period in 2015, where right here we have 1.5 degrees Celsius. Still a considerable El Nino, but we've seen a couple stronger. And then we've got our outlook. This was actually updated nearly a month ago, but we're favoring El Nino to continue through next spring when it's kind of chances of it going back to neutral are greater than chances of El Nino continuing. Now that's fantastic news. However, we already know that considerable heat for next year is kind of it's a given. It's pretty much baked in, we'll call it. So hopefully we'll return to El Nino neutral, kind of like what happened with the 2015-2016 El Nino, where it kind of went back to neutral, but that didn't mean that the remainder of 2016 got cool. 2016 stayed very warm. So that's just something to keep in mind, and we can look at the different outlooks, but it's looking likely that we'll be going back to ENSO neutral in the spring. This is also something that gets updated about the middle of every month. It was updated October 19th. I tend to look at this every month when it comes out just to kind of plan my winter. However, I will say in the past year, this has not been very accurate for my region compared to how it used to be. But it has a nice summary here that, yes, we have a moderate to strong El Nino. We can anticipate it to continue through next spring. Really quickly, let's jump over to the Arctic sea ice. We have extent has increased faster than average, which is very welcome. We can see that it's regrowing nicely. Still, well within, or I should say, still well below what the 1981 to 2010 mean or median is. But and also keep in mind that this is new, less than 1 year old ice. But it's good to see that it is regrowing a little bit faster than average. So we'll just call that a minor victory in the grand scheme of things, even though, long-term trend is down. So that brings us to this bit of news, which is kind of freaking a lot of people out. Because for the, kind of the first time within this record being from 1982 to 2011, well, actually from 1982 to present, because if we're looking at this data set, we've got partial 1981. This is the data set it's coming from. So basically from then until present, but it's the comparing to these years for the mean. So we have a 6 sigma event, 6 standard deviations away from that mean. So when you look at the red line, it looks kind of like, oh, wow, like hotter than ever, like this is unprecedented. It is unprecedented in terms of its relationship to the mean. sea surface temperatures globally have been hotter than they are now. But to see that in context, we need to understand that this dashed line here, right in the middle, is our 1982 to 2011 mean. That's it right there, and it's just been bolded since I'm hovering. Right there it is. So the temperature we're talking about as November 6th and 5th, whatever, is 20.8 degrees Celsius. And we can see that the mean that it's compared to is 20 degrees Celsius, so a deviation of 0.8 degrees. Now, it's not basing the Six Sigmas on a number, but rather the relationship of this number to other numbers in the record and the likelihood that they are to occur, on a given date. But as we can see about these temperatures, starting from October, we've had, the same temperatures or hotter going all the way back until like late February. So we've also seen hotter temperatures in like spring of 2016. We've seen hotter temperatures than this spring of 2020. Sea surface temperatures globally, on average, have been warmer a few times. So when we look at this, understand that, it has been warmer, but the relationship between this and the mean, and which includes all of these years in the record, has never been a greater departure from that mean than now. But if we look at the record so far this year, it's been above 4 standard deviations pretty much ever since, what was that, probably February or March or something. So it's been unprecedentedly hot for a long time, but we can say both this year, not just both, but this year and in a few previous years, there have been hotter moments. Now, why is it that if our departure here is unprecedented, that our departure in the 2015-2016 El Nino was larger than it is now? Those things don't seem to agree with each other, right? If it was much warmer, if our deviation from the norm in 2015 was greater than it is now, how is it that this deviation is greater now than it was in 2015? Well, the answer basically is that this map is talking about global sea surface temperatures, and the El Nino is only measuring equatorial Pacific, which is just one particular part of the global ocean. So if we look at sea surface temperature anomalies as they were November 7th, we can see our El Nino here. It's pretty strong. We've had stronger, like we noted before, but we also have serious deviations here in the northwestern Pacific. We have some in the southern Indian Ocean. Up here, we have a few spots that are also cooler. So while our El Nino has been stronger in years past, just a couple of times really, I mean, this is a pretty decent one we've got going so far. What we have is a much higher starting point globally for the global ocean. And part of that is because we had these 3 years of La Nina, the past 3 years, during which time a lot of heat got stored in the ocean because they were hot years, right? And a lot of that heat was stored in the ocean, and now we have kind of just a much higher starting point. So if we look back at this record, and we're talking about starting points, we look here at the previous record for the end of the calendar year, like December 15, 2015 going into 2016, and it comes back over here, and we have the previous record springtime, or I should say Northern Hemisphere springtime. That previous record kind of started off of a record at the end there. So if we imagine what next year's early months are going to be like and where it's going to be departing from, it's going to be a much higher temperature departure, for quite some time. And that's because we've had our global oceans absorbing so much of that heat that we just have a much higher starting point. And that starting point is, climbing higher and higher. If we look at these years, these recent years, they're all the most recent years, generally, even if they were not necessarily El Nino years, right? So, again, El Nino is telling us departure in temperatures for the equatorial Pacific, whereas here we're looking at it globally. So, just to summarize, yes, we have seen higher temperatures, global average temperatures, than this point. And we see those at places like all along here, but we're talking about our departure from the mean here, which is, while waters have been hotter, relative to where they should be, has not really been any greater than now, at least not in this record. Again, it's a 40-year record, basically. It's giving us the mean, but there are more than 30 years in the record that we're talking about here. So if this mean included years between 2011 and 2022, it would be higher, and that departure would be smaller, right? And considering that those years between 2011 and 2022 were some of the highest, then that's something to take into consideration. But also, on the flip side of that, we're looking at a relatively warm time in history period, right? If we were to be comparing this to the pre-industrial mean, which we don't really have that data, but if we had it, and we were comparing this to the pre-industrial mean global sea surface temperature, then it would be greater than 6 sigma. So we're comparing it to a relatively recent mean. It would be a smaller deviation if we had years 2012 through 2022 included in the mean, but it would be much, much greater if we included pre-industrial mean, if we included if we had so much more data to work with, but we don't. So we are working with what we've got. That's probably about it for what I'm going to talk about in this little update. Again, if you're seeing this and freaking out, remember that temperatures, global average sea surface temperatures, have been higher than this, but the departure from this mean has not been higher than this. So just something to keep in mind. It's like, yes, the situation is serious, but again, it has been warmer. So freak out, but not too much. Thanks for listening.